Okay, and here we got a grid line and also the in 3D view. Now we will going to create the material. We can quickly define material property. From here, add a new material, and also the region we take the United States, and material type should be a concrete, and standard we take a user because we will create the own material. Okay. Yes, material name. So I will create the concrete with the concrete strength about 25 megapascal cylinder for the slab and the beam, and 30 megapascal for the column and shear wall. Now I can say C25 concrete, and specific Y should be 24 kilonewton per meter cube, and modulus of elasticity. We can calculate from this formula in ACI concrete property. Here we can calculate the young modulus of elasticity of the concrete. Okay, from this formula I can put here about the 25 megapascal, and we up to calculate with 26 612 megapascal. We copy and insert here. Yep. And Poisson ratio for the normal concrete will be 0.2. Coefficient of thermal expansion A, we can take the default and simulate the program of auto calculation for us. And for the design property data is more important. We can modify and the grade. This we can specify by our own. We can say FMC 25 ampere cylinder. This we can edit the name and the node for the concrete type in the 28 day H. Then design property for concrete material, yes, important. 25 the same our grade. Okay, and okay, and after we can add a copy of material because we will create another one for the column and the shear wall. Should be C30. Specify this will be the same, but here we can calculate one more. Should be 30 ampere. Yep. Can get here, copy, and put here. Yep. Modify material. Should be 30, and you can change 30. Yep. Okay. 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 This we finish to create the material for the concrete, and the next step we will create the material for the steel reinforcement. The same place, define material property. Here, add new material. The same, the region will be the United States. The material type should be the rebar, standard for user. Yep. And for the reinforced concrete property, actually the reinforced concrete we can divide from the grade of the reinforced concrete, but this we follow in Cambodia. Reinforced concrete deformer, we select the grade 60 and the gel strength to be 400, and the reinforced syrup grade 40, the gel strength should be 235. But from the ASTM, the grade 40 be about a bit higher than I choose. But to be safe, because in Cambodia we provide only the the steel reinforcement with the yield strength on the 235 for the round bar, and also 400 megapascal for the deform bar is a lots of supplier. So I decided to choose this one, and the grade that we follow this, but actually yes, I know that the grade of the ACI and be a bit higher than us, but to be soft, we take this one. Okay, back to the Etabs. I can say this would be the T235 material type would be rebar and specific wide density. For the reinforcement concrete, specified density to be 78.5 if we calculate to the Newton per meter cube should be the should be 78.5. Yeah, we put, or you can specify the mass density also. The mass density will be the same, 7,850. Both value the same. You can put the same. So with 50. And the model of elasticity should be 2 and number 5 or 0 after. We mean the 200,000 megapascal. And coefficient of thermal expansion A, we can put the default. Design our property data. Just I change the grade for 40, and the minimum yield strength should be 235. And from here, we can add 1.5 of the yield strength for the minimum tensile strength, and now expected the strength to be 1.1 out the minimum of yield strength, and also expected tensile strength we 1.1 out the minimum of tensile strength. Okay, but actually this the information we can take from the catalog of the rebar and from the supplier, but don't know right now. I will put just estimation and 235. Yep, 1.1 multiply 235 and 1.1 multiply 352.5. Yes, then okay. Add a copy. Here should be T. We put 400. Specific way the same change here. Correct. 60. 400, and also the same 1.5 multiply 400, 1.1 multiply 400, and also the last one 1.1 multiply 4 or 600. Okay. Yep. Okay, and okay. Yes, that's all. We already create the material for our project. Okay, for the next step, we will create a section for the beam for the project. The first we can estimate from the ACI the section pre-estimation. For the beam section, we can take the clearance span, and we can take the interval or number up from 1 over 15 to 1 over 10 multiplied by length to calculate for the dip, and also the interval 0.3 to 0.6 multiplied by the dip of the beam to get the Y of the beam. And slab thickness also the same. We can take the parameter. The parameter is equal to 2 times of the total length, long side and short side of slab, and divide by 108 to get the minimum thickness.